Hello students, it's me again. We're going to be doing some binomial distribution today, which is the next thing after working through simple probability distributions. So let's get started. So binomial distribution, we're going to introduce this by thinking about this question here. I'm going to roll a dice 5 times. What is the probability that I get 2 6s? So what we want to think about here is, hang on, just give me a second. Okay. So what we want to think about is what happens when we roll 5 dice. So here is some dice. I normally like to do this as a kind of classroom task if I was in a lesson. There's nothing more exciting than the sound of clattering dice in a classroom, so I've got my own dice to simulate the noise of dice being rolled to make this as exciting as possible. So I'm going to roll 5 dice and then I'm going to see what happens. Hey, look, I rolled them, so didn't get any 6s. So going back to this, what's the probability I get 2 6s? You might be tempted to say something like, well, the probability I get 2 6s, well, say I get 2 6s, well then I'm going to have, I'm going to be having 1 out of 6 times 1 out of 6. Because the probability of getting a 6 each time is 1 out of 6. And then we might think to ourselves, well, that's 2 of the rolls. The other 3 rolls have to not be a 6. So those would be 5 out of 6. Oh, pressing the button on the pen. 5 out of 6 times by 5 out of 6 times by 5 out of 6. And then we can kind of think, what does this give us? So I'm going to do this in my calculator. I'm going to do 1 out of 6 to the power of 2, just to save myself a little bit of writing, multiplied by 5 out of 6 to the power of 2. And 5 out of 6 to the power of 3, sorry, not 2. So that's going to give us this fraction or this probability. Just decimal to both probabilities. So that gives me 0.0161. So there's a problem with this because this is not the only way that this could happen. So if I take my dice and have a look at them again, let's say I roll 5 dice, or I roll a dice 5 times and I roll it until I get 2 6s, which I'm not going to do live because, oh, I got it. So here, 2 6s, but they didn't happen in this order because what I've done here would assume that these first 2 dice, so here I've got 1 out of 6 and 1 out of 6 in the first 2 entries. That assumes that the first 2 dice would be 6s, but here in fact it was the 3rd dice and the 5th dice. So this makes it a little bit more difficult to calculate this probability because this is not actually the answer. 0.016 is not actually the answer. So what we have to think about is how many different ways are there of rolling 2 6s. So this is exactly the amount of ways that it could be. So I've just done a little bit of simple combination stuff here. So this is my first entry, which is actually the probability I've just calculated. So if I say, well, the 2 6s are appearing as the first 2 dice, then this is what we get. So this, you can see, is the same as what I've got here in the first row. So S being 6 or success is what I was thinking of when I wrote this. F being failure. So success would be getting a 6, failure would be getting anything else, which is 5 out of 6 probability. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ways that this can totally happen. And what you'll hopefully notice, if I just do a little bit of a quick example with this second line. So the second line has 1 out of 6 times by 5 out of 6, then times by 1 out of 6, then multiply by 5 out of 6 twice again. So doesn't take a genius to work out that this is actually the exact same calculation as there was in the first line. It's just been put in a different order. So this is going to give us the exact same answer, 0.0161. And these are all going to give us the same answer. All of these outcomes are going to give us the same answer. So what you should hopefully remember, it's a little bit like a probability tree. If you look at a probability tree, you multiply when you go along the branches, and then you add all the different options that satisfy the outcome that you want. So here I've got 10 possible outcomes that I want, and they're all going to have the same probability. So actually what I need to do to work out the total probability, the actual probability of getting 2 6s in any possible order, is do 0.0161 times 10, because there's 10 possible outcomes for this. So that is going to be, quite obviously, 0.161. And that is the answer for what the probability is of getting 2 6s if I roll a dice 5 times. So this seems like it could be pretty annoying, because I could say what would happen if I rolled a dice 20 times, what's the probability I get 2 6s? And you have to work out all the possible ways that 2 6s could appear out of 20 dice rolls. But it's actually it's much easier to do than that, because you might recognize that what I'm actually doing here is how many ways are there of choosing 2 things from 5. So this 10 that I've got here, it's actually something we should remember from pure maths, hopefully, which is that it is, here, 10 is actually 5 choose 2. Or we might have written it in a kind of bracket form, 5 choose 2, like this. Okay, so that is actually what gives me this number. So all I need to do is think about what is the probability, and then multiply it by 5 choose 2. Or if I was choosing, say, 3 6s, I'd say 5 choose 3. So this is known as the binomial distribution. So essentially, this is what we have. And there's a bit of lingo here that we need to learn. You'll see these sorts of things in the exam. So this first line, if x wiggly line b and p, this bit is saying if x follows, so the squiggly line means follows, if x follows binomial distribution of NP, and n is the number of trials that you're doing, so where n is the number of trials and p is the probability of success. So in our dice we did 5 trials. The probability of success was 6th. So I would go back here and I would say for this one that x follows, in this case where x is probability of rolling 6, so x follows the binomial of 5 1/6. Okay, so NP. So the probability of success is a 6th. There are 5 trials. So this is exactly what I just did as well, because you'll notice as well from our dice that what we were saying was, well, there's 10 possible ways, which was the 5 choose 2. So this is for the dice particularly. The probability of success was a 6th. We wanted that to happen 2 ways, 2 times, and then the probability of not success is 1 minus that, which is 5 out of 6, and there was 3 possible ways that could happen. So this is actually, if you look at my calculator on the right hand side of the screen, I still have 1/6 squared times 5/6 cubed, but I was just doing it 10 times, 10 different ways, because these could be permuted into 10 possible different orders, because obviously multiplication doesn't matter what order you do it. So if we're using binomial distribution, there's 4 things you need to remember for the exam. So there's going to be a fixed number of trials, which we call n. There are 2 possible outcomes, i.e. success or failure. There's a fixed probability of success, and the trials are all independent of each other. Okay, so our dice was a perfect example of that, because we did 5 trials. The outcomes, success or failure, was either rolling a 6 or not rolling a 6. Although you do have to be careful, because sometimes that can be confusing, because you think about a dice, there's actually 6 possible outcomes on the dice, but only one of them we considered a success. So in effect, 1, 2, 3, 4, and 5 were all the exact same outcome. Fixed probability of success, 1 over 6, and the trials are all independent of each other. Well, if I roll one dice, it doesn't affect what happens on the next dice. So this is quite easy to do, really. If we have a simple question, like here I've said extremely unexciting question. The variable x has a binomial distribution with n equals 7, p equals 0.1. So we have to write x follows binomial of 7, 0.1. And then we can just use the formula to do this. So the formula is written at the top there. So I'm just going to say, well, the probability that x equals 2 from this binomial distribution is going to be 7, choose 2. Then it's going to be, wait, what am I doing? Probability 0.1. Ooh, that didn't go quite right. 0.1 to the power of 2 times by 0.9 to the power of 5. Okay, the powers are always going to add up to the n, the number of trials, and the probabilities are always going to add up to 1. So we just go over to the calculator here and we'll just do this. Where am I going? So clear everything. So NCR. So we're going to have, what is it, 7 choose 2, 7C2, so we'll just say that's 21, and then we'll times that by 0.1 squared. Let's type on the 0. Oh, why did I put a fraction in there? Here we go. 0.1 squared times by 0.9 to the power of 5. 0.1240. Let's say 0.124. Okay. Similar question. I mean, I would hope that's quite simple. You can just follow the instructions from the formula and get any individual outcome, like any individual probability. So, similar question that we have here is the variable x has a binomial distribution with n equals 3 and p equals 0.45. What is the probability that x is less than or equal to 2? So we have to do a little bit of thinking here, because we're actually looking at a less than or equal to sign, which is a little bit different. So less than or equal to 2, well, I'm just going to think about what the possible outcomes are for that to be the case. So if it's less than or equal to 2, it could be 2. So it could be the probability that x equals 2 plus the probability that x equals 1. And then you must not forget, you also have the probability that x equals 0, i.e. there was no successes, because like on my dice I could have rolled no 6s. So we just need to work out the individual probability of each of these things and add them all together, and then that's going to give me less than or equal to 2. I'm not going to do that now because that would just take a bit long in the video, make it too long, but you can do that yourselves. Just use the formula that's written up here, and that should be fine. So in order to save us a little bit of time, this is actually a nice topic to use your calculator on as well. You must not forget about using the formula for this, but you should be using your calculator where you can, because it will save you a lot of time. So in our calculator, I've got a calculator like picture here. This is the option we want. We want binomial PD, binomial probability distribution. So my calculator's over here. The way we get to binomial probability distribution is that we go to 7. Okay, so if I go back to the menu, I can do that with my arrow keys as well. Go back. It's a bit dodge. There we are. So number 7, distribution, and then we go to binomial PD. We want to go to variable, and then we just want to type all the values in here that are relevant. So it says the probability of a bolt being faulty is 0.3. In a random sample of 20 bolts, what is the probability there? Exactly 2. So we're just going to say, well, x is 2, because that's the outcomes. The number of trials is 20, and the probability of fault 0.3. And then we just press equals, and we have the answer. So question A, we're going to have probability that, just call it x equals 2, is 0.0278. Less than 340 volts. So we have to be a little bit careful here. We're going to write this out first. So less than 3 is a similar question to what we had at the bottom here, this bit, but it's got a difference. It's got a different inequality sign. It's just less than, not less than or equal to. So less than 3 would actually be the probability that x equals 2 plus the probability that x equals 1 plus the probability that x equals 0. So 2 we've already worked out, saved us a little bit of time, so 0.0278. And then because we're doing it on the calculator, we can do this a lot quicker now. So I can just press Alt AC, it will take me back to this screen. I'll say, okay, what's 1? It's a very small number, and then well, 0 is going to be an even smaller one, isn't it? Yeah. I can't bother to write all those out, but that's what you do. You add them all up. It's going to take too long. So that's the first bit of this. This is a little bit of a quick run through because we want to get on to doing the next bit quite quickly. This is quite similar to what we were doing up here anyway. So if you want to do some questions from a textbook at this point, I would just say just do any question with an E next to it. There's only a few of them in the exercise for this. This is exercise 6B. So you want to be doing those questions. I'm going to move straight on now